Hello everyone and welcome to our first session about VirusTotal API. I am Alexandra Martin from the Customer Success team, and today I'll briefly introduce you to the VirusTotal API, and then we will jump directly into some real-life use cases that can be automated. But before starting, please remember to add your questions or comments in the question section below, and at the end of the session I'll try to answer them. Then if there are too many, I will post the answers to the rest of them so that you can go and check them anytime. Additionally, you can also contact us at contact@virustotal.com, and if you do so, please indicate that your request is related to this webinar so that we know how to manage it, and we will be happy to help you. And of course, any kind of feedback will be highly appreciated. So let's get started with the introduction. Okay, just to give you more context, this session came up from the feedback I think some of you gave to my colleague Alexei Fish during one of his previous sessions. And based on that feedback, as a first step, we published the upgrading from API v2 to v3, what you need to know post. And this webinar is like the second step showing VirusTotal API capabilities. Okay. So in this post, we focused on the migration from API v2 to v3 topic, but it is also useful to everyone interested in knowing more about the API. It also shows the main reasons to use or to migrate to VirusTotal API v3 here. And in addition to the benefits listed here, it also allows you to integrate VirusTotal lookups with any internal system that you might have, and to automate all kinds of tasks that you might normally perform in the VirusTotal web interface, because it allows you to interact with all VT products like Live Hunt, Retro Hunt, collections, etc. And it is also up to date, right? So anytime a new feature is launched in the web interface, it's available also on the API. And then here you have a table, this one, that summarizes endpoint correspondence between v2 and v3. The listed endpoints here are linked to the API documentation. So if you want to check how to submit files larger than 32 megabytes in v2, here you have the documentation and how to do it via v3. Here. Then here we have a link to the GitHub repository that we have. And here we have example of basic use cases are called snippets in raw Python using only v3 endpoints shown in the previous table. Okay. Now, the API documentation website shows the same information with even more detailed differences between the two versions of the API here. And an additional cool feature that it has is the code generator. So for instance, if you go to any endpoint, like for instance, getting file report, here you can select this button and then select another language, like for instance Python, and automatically the code snippet here is updated to Python. You can then copy it and use it in your platform. Okay. And now let's jump into the use cases, and the first one is about tracking APTs via API. Okay, so to demonstrate how we can leverage this, my colleague Alexei has made a dashboard to track an actor footsteps in VirusTotal dataset, And apart from the charts that you can see in this image, it also provides us with lots of recent IOCs such as files and their AV detection radio, collections that they belong to, and crowdsourced detection rules matching them, and also IP addresses, domains, and URLs belonging to collections related to those threat actors, and also graphs and also comments. But let's take a look on it. Let's see the dashboard. Okay, here we have it. Here you can select the threat actor you are interested in, and then here you have the description of that threat actor, of that threat group, and the dashboard is split in 3 sections. The first one is about charts, and here you can see statistics based on the number of files related to this group, and based on AV vendors' verdicts. You can also see files based on crowdsourced rules, Yara, Sigma, and IDS. And then domains based on collection entities, and files again based on collections, and some also some geographic statistics. Then the second section shows related IOCs. Here, file samples based on AV vendors, collections, and crowdsourced rules. And this is what it shows, like the hash and the AV vendor verdict. For collections update, it shows the file and the collection that that file belongs to, and crowdsourced intelligence rules, again the hash and the Sigma, the Yara, and the IDS rule that matched that file. Then for network indicators, we have domains here, again domains versus collections, and the same for URLs. Again, here we have the collections, and for IP addresses based on collections. And the last section is about community efforts, and here we have graphs, those graphs that are related with a threat actor based on name or description or aliases, collections, and here we have the name of the collection, the author, and the last one is about comments, and here we have the list of files that have been related to this threat actor based on comments. Then we have again domains, URLs, and also IP addresses related to this threat actor based on again comments. Okay, so for this dashboard, my colleague has used the official Python client for VirusTotal, but I would highlight that we have also an official Go library, and as a work in progress project, the Java library. So if you prefer to use Go instead of Python, you can definitely do that. Then with the Python client, you can retrieve any VT object and operate it how you would operate any Python object, right? And not just that, but you can also perform VT intelligence searches, which is actually what is mostly used to get the all the data behind this dashboard. And we have detailed manuals for the Python client too, that you can check anytime you wish. So, as I already mentioned, VT intelligence searches combined with the advanced corpus search endpoint are used to get the data behind this dashboard, and here we have the documentation of this advanced corpus search endpoint, which requires the VT intelligence query here and the API key. Then, for instance, in this first example here, we are fetching collections related to SOFACI, and we are filtering that mostly based on collection name, right? And associated tag here. And we are only using two aliases, like APT28 and SOFACI, but you can put as many aliases as you wish. And on the right, we have the associated Python code with the VT library. And this is the endpoint that it uses. And this is the VT intelligence query. It's the same one as here. Then in the second example here, we have a very special search query for graphs listing only. Here we are using a different endpoint, which is graphs. And in fact, it is not really a VT intelligence query, like in the first example. This is a query for searching graphs specifically, and as you can see, it has different parameters, right? And this special query not only filters by name, but also by actor and by label. Now here we have the list of queries used in the dashboard, but with less aliases. So for instance, the first example gets the files identified by AV vendors as related to Lazarus Group based on the AV vendor verdict by using this engines search modifier here. By the way, you can use the entity file modifier or not, because when you are using engines search modifier, automatically VirusTotal will search for files. And this query here is associated or is used, for instance, here to list 5 samples by AV vendor verdict. Now, the next one, the second example, here we are asking for all files matching any YARA, Sigma, or IDS crowdsourced rules related to Lazarus Group, again by using crowdsourced YARA rule search modifier, crowdsourced IDS search modifier, and the other one, the Sigma rule search modifier. And again, you can use the entity file modifier or not, depending on what you want to do. Then this is related to this data here, crowdsourced intelligence detected by YARA, IDS, and Sigma rules. And here we have the list. And I think that we have also in charts, where is it? Here. We have the same data here in the charts. Okay, now, third example. And this is to get a list of IOCs related to the thread group based on comments, the comment search modifier here. And in this case, you have to specify which type of IOC are you interested in. So instead of the X here, you can put file, URL, domain, or IP. And this is related to the comments, files, domains, URL, and IP addresses from comments here. And the last example, this one, is to get a list of collections based on name and tag search modifiers. And this would be related to the collection section here. Now, this is just an example, right? You can use other queries in your dashboard with more restrictions, like for instance, only your trusted AV vendors verdicts, or I don't know, only your trusted collections owners, or your own set of aliases, or even filter out files with detection ratio less than X%. Next use case is about vulnerability management. And here we have another dashboard. So I've made this other dashboard to track in the wild vulnerability exploitation trends based mostly on files with additional context from collections, VT collections, and Mitre CVE's repository. Then its purpose is to help to develop smart patching strategies based not only on internal telemetry but also on in the wild exploitations. Now let's see the dashboard. Okay, so this dashboard is split in two parts. The first one is the historic results, and the second one shows you the last 3 months of results. Here we have the summary. Here it shows you the number of CVs seen during these last 3 months, the number of submissions, 5 submissions, and this is the query that we've used in order to get the data, and I will explain it a little bit later. Now here we have the submissions charts, and here you can see the vulnerability identifier, and here we have the number of submissions of files detected to exploit those vulnerabilities here. And here we have the same data but with a timeline chart. Now, if you click on any of these CVs here, it will automatically expand and it will show here the details of the CV based on Mitre repository, and here the list of VirusTotal collections that are related to this CV. Then here we can see the timeline again for the specific CV, that the one that was selected, and here we can see a pie chart that shows the types of the files exploiting that vulnerability. So in case any of you want to replicate this dashboard, this is the architecture I followed. Then the first component is the data generator, and it uses specific VT intelligence searches to retrieve the data from VT dataset with the advanced corpus search endpoint that we saw in the previous use case. Then it filters the data provided by this endpoint, and with the selected information it generates an JSON dictionary, which is then stored in the second component, that is the data storage component. Then the third component gets the relevant data from the data storage component and generates infographics to be visualized by the user. So the data generator makes use of the VT Python library. It is implemented on Google App Engine, and it is automatically executed through Google Cloud Schedule job. Then the JSON formatted files are stored in Google Cloud Storage, and for the last component, the visualization component is hosted on Google App Engine, and it is developed in Python and makes use of Plotly library. However, this is just an example, and you can use the approach you wish or better suits your needs and infrastructure. Now, to better understand the data behind this dashboard, it is important to remember that its main purpose is to identify exploit files and when and how many times they have been updated or rescanned. Then, to identify a file as an exploit of a specific vulnerability, we have the tag CVE search modifier here, and we focus on the 2022 and 2023 vulnerabilities by using the wildcards here. Then The first seen dates here are only to restrict the search to a time frame, and the rest of the filters here are to avoid bias. We are trying to count only exploits, right? Not also the compressed files that contain them. And this is because in VT, anytime you submit a compressed file, the embedded files are analyzed as well, so you need to filter out that. Now, what data are we interested in? We need here the file type for the last chart in the dashboard. We need also the file tags to identify related or associated CVEs. And we need also the file hash for submissions relationship. And this is because submissions are not available in the main file report. For instance, if you go to the file object here, you can see that you can see that submissions are a list of submissions, and they are only available via relationships. So that's why we need to use this endpoint that gets the relationship or the object, the related object that you indicate here. Okay. As for extra data, the collection data that is expanded when you select the CVE in the dashboard, for that I've used this query which combines the tag CV search modifier with the entity collection. Very simple one. And just to clarify, the tag CV data comes mostly from AV vendors. So in your case, you can use other logic, like for instance, only your trusted AV vendors' verdicts. You can also filter out files based on their detection radio, and you can even take into account the crowdsourced EROs, like in this example here. But if you do this, please note that there could be rules with the CV dash and the year name, or with underscore. Next use case, IOC stream notifications and API automation. Well, in this case, we've changed the approach to the consumption of VT notifications in an automated way. So IOC stream is the new centralized notification feature that is replacing the previous live hand notifications, and by now it only shows or notifies files matched by your active hunting rules, right, by your live hunt rules. But soon other sources will be included, such for instance thread feeds, thread actors, and users. Then, to be able to be notified of new IOCs from these new sources, users will have to subscribe to them. And we are working on notifying not only files but also URLs, domains, and API addresses, but this is still in progress. So if you go here, here you can see all my notifications, and of course all of them are files. Now, as for the use case, let's say that you receive other feeds from other sources, not only VT, right? And you want to have all of them together, or maybe you just want to integrate them with your internal systems for other reasons. Well, you can do that through this endpoint here. Okay, and here you have the documentation of this endpoint, and it also allows you to filter by different attributes from the notification, right? So for instance, if you have notification from 3 different Yara rules, then you can filter here and get only the notifications from a specific one. Okay. And then here we have an example with Python, raw Python, and again we are using the API key as an environment parameter, as an environment variable, and here we have the filter, right? So as you can see here, we are using several filters at a time separated by a space. So that's the way to use them together. And then this is the endpoint, and here we are using the filter URL safe encoded, and this is the example that you can use. And now the last use case is something a little bit different, and this time is about VT users and VT groups management. Okay, for this we have made a compilation of the most repeated requests we have received from our customers and others that we think are useful too. In the following examples, we have used raw Python scripts instead of the VT library, and the API key is an environment variable. Also, please note that only admins can perform most of these use cases regarding users and group management. Now the first one, maintain group updated. This is about employees changing roles or even leaving the company. In this case, you might want to keep your group up to date by removing users that shouldn't have access to VT. You can then automate that task via API instead of doing it manually. And this is an example here. In this case, we have used a plain text list of users, but you can get users from a config file or database or whatever you wish. So here is the list, here is the API key, and this is the endpoint used for that. Now, next use case, welcome to VT. This is very useful for new customers or new teams of a company that need access to VT. Adding them manually to the VT group could be tedious, so instead of that, you can use a simple script like this one. And well, please note that for removing users, we are using the user ID, while for adding them to the group, we are using the email address because that's the only way to add users, right? So here we have email addresses and here we have user IDs. Then, while the removing endpoint works with only one user by request, the adding user endpoint allows you to add all of them with only one request with a dictionary as parameter. So here we have request by user, while here we are creating the payload, like the dictionary with all the users, and then we are requesting just one time. Okay. Next use case, list group members. For example, when there are a high number of users in a group, it could be tedious to identify all of them, and in the website you have to click the three dots button to load the next batch of users, like again and again, right? But with the API, you can get the entire list of users with a simple script like this one in the example. Next use case, reset API daily limit quota. In this case, we work again with dictionaries as parameters, but unlike the previous example, this endpoint works with only one user per request. And this is the structure, right, you have to use with this allowed attribute here where you indicate the API daily quota limit. So in this case, 300. In fact, keep in mind that what you do with this endpoint is patching a user object, so you can fetch a user object to see its structure and what you can or what you want to modify based on that structure. By the way, attributes that are not included or indicated in this patch request will not be changed. So you have to specify only what you want to modify, not the entire object. And also keep in mind that there are attributes that can't be modified, right? Then, if you want to block the access to the API to a specific group of users, you can just configure this allowance here to 0, and they will not be able to use the API. And last but not least, the consumption, and this is very easy one. For API consumption, you have two endpoints or two options, one for the entire group and the other one for a specific user. Both endpoints allow you to fetch a maximum of 30 days of consumption by request from the last 60 natural days. And the second option, which is only available for users, shows you a summary of API endpoints used by the user during the current month.